Welcome to Maths for You YouTube channel. A past question on differentiation and integration. Fx equal x squared e to the power of kx, where k is a positive real constant. Show that f dash x, differentiation of fx, equal x times e to the power of kx times kx plus 2. Show that. So let's do the differentiation first. Part 1. All right, the fx is x squared e to the power of kx. The k is an element of positive real. So that's what. Right. Okay. Just a simple differentiation. It's u into v format. So u time dv by dx and then v time du by dx. So if I could do that in the to function multiple. So f dash x, well, x squared term differentiation of x squared is 2x e to the power x kx plus x squared, keep x squared, and differentiation of e to the power kx is e to the power kx, and differentiation of kx is k. Then let's rearrange it, also simplify. 2x e to the power kx plus kx squared e to the power kx. We can take x common, we can take e to the power kx common. If you do that, x equal e to the power kx in bracket kx plus 2. So that's the first part. That is what we have to prove. Yeah, x times e to the power kx and kx plus 2 in bracket. That's part A. Part B, find the value of k for which the graphs of y equal fx and y equal f dash x have exactly 1 point of intersection. Find the value of k for which f equal exactly 1 intersection. So that means fx equal f dash x, if they are intersect each other. So just to find the value of intersection, so fx equal f dash x. Fx is x squared e to the power kx. F dash x we have found x times e to the power kx, kx plus 2. We cannot sort of simply cancel anything. We just bring it so that we can get the true value. So right, I just brought the right hand side to left hand side. The left hand side is already kx e to the power k. I just sort of rewrite it. E to the power kx times x squared minus again e to the power kx times x kx plus 2 equals 0. So if I could take e to the power kx out as a common factor, and what we have, x squared minus x times kx plus 2 equals 0. The k is a positive real number. Even if it isn't, e to the power kx cannot be 0, because if it's any value, it's 1 over value. So just e to the power kx cannot be 0. Therefore, we have left with x squared minus x times kx plus 2 equals 0. So if I could remove the bracket, x squared minus kx squared minus plus minus 2x. So now take x squared out from these two components. So it's 1 minus k minus 2x equal. From these two, x as a common. So what we have, x times 1 minus k minus 2 equal 0. So if I could, so the two values, one x equals 0, the other one is x times 1 minus k minus 2 equals 0. From that, x equal 2 over 1 minus k. So here, if you look at if k is 1, that will be 1 minus 1 is 0, so the x is undefined value. Therefore, only value x can take, x equals 0, the value can take. So it intersects at the origin. Well, it just x-axis and then not origin. You need to find that. If you could apply that x equals 0, yeah, it is origin 0, 0. So it will actually intersect at origin. But if it's x equal 2 over k minus 1, it will actually intersect if k not equal 1. Otherwise, it will make it undefined. So it just k, it cannot take a value of 1. So k is anything other than 1, k will take. So we can't define it exactly what the k value is. K cannot take 1 if it's that value. But they says it's only one value or intersect at origin. So this is k minus 1 is undefined. Therefore, we could take it k equal 1 for the condition of if it's 1 intersect. If it's 1 intersect, x equals 0. So the other one is 2 over 1 minus k cannot be an intersect or cannot be a value for x. Therefore, only way that it cannot be a value for x, k equal 1. So k equal 1. So it's, you don't stress as much. So let's move on to next part. So first, yeah, the first part is the B is to find the value of k, which the graph that exactly 1 point of intersection. Yeah, if it's 1 point of intersection, k must be 1. That's what we said. So if k1, that is undefined, so it left with one value. So right, k equal 1. Right. Step next part. Let gx equal minus 2x e to the power of kx divided by k. The diagram below shows section of graphs f and g, x greater than or equals 0, well, from the diagram. So it's just a little diagram. So it's the first one is f exponentially going up, and then g exponentially going down. So let A be the area of a region bound by the curves y equal fx, y equal gx, and the line x equal 2. Write down a definite integral that gives the value of A. Right. So before we do this, so what does it integral means? The area, finding an area, we have to integrate this. So the area under the curve by integrating the y function. F and g, it is y, yeah, this one f, I'll go through it in a minute. Before I go through it, yeah, let me go through it. Okay, I'll put a little sketch here, x-axis, y-axis, and origin, and the curve fx equal x squared e to the power kx, and the gx equation is minus 2x e to the power kx over k, and the line x equals 2. There are I'll just split the two areas, A1 and A2. So A1 plus A2 is A. That A we need to find. There are two area. The reason I just put it two area, if the area A2, you can see that area A2 is below the x-axis or the negative part of the y-axis. If that's the case, when we actually integrate and find the value, we have to negate to get that actual area. So if you take it gx and integrate it and put this limits and all, the value you get, you have to negate to get A2. So it just simply is minus. So it's positive wouldn't give you the area. It will give you the negative side of it. So let's do that. A1, A2. Right here. as I said, the first one, fx, x squared e to the power kx dx, and the integral 0 to 2, that's the limit. And then because of that, a2 is, this is a1, this is a2. So a2 is the negative side of the y-axis. We need to, instead of adding, we need to subtract. So minus integral of 0 to 2, and minus, of course, the gx is minus 2x e to the power kx over 2. So if you look at it, the integral is, limit is 0 to 2, and then integration with respect to x. So we can combine both functions. If you do combine it, so the first one, x squared e to the power kx, and of course integral 0 to 2, and minus to minus plus 2x e to the power kx k dx. I purposely wanted to take k, 1 over k, out of as a bracket, as a common. So if I do take 1 over k, then we have to multiply the first one by k. So that is kx squared e to the power kx plus 2x times e to the power kx dx. Then if you further simplification, 1 over k e to the power of, the integral is 0 to 2, x e to the power kx can be taken common. So x e to the power kx inside kx plus 2 integral. So doing this integration, if without any help, it takes it's a bit of a work. But we have, if you look at the first part of the differentiation of the function, so the function is fx, and then differentiation of the function f dash x is x equal. So in other words, we have this function x integrated to the x kx plus 2. So if you integrate the f dash, it gives you fx. So this one, if you look at it, this is f dash x. So integral of f dash x dx equal fx. That is exactly what we have here. So the integration of that is the first part helping us. So we actually found the differentiation of x squared e to the power kx is x times e to the power kx times kx plus 2. So if you do it the other way, the differentiation of x times e to the power kx times kx plus 2 is, which is f dash. So integral of f dash is fx. So that is simple as that. So we found the integral without any sweat, because of first part we are applying it. So 1 over k, and the integration is this, x squared e to the power kx, and the limits. If you put the limits, 1 over k, if you put 2, x for 2, there's x squared is 4, e to the power 2k, because of x is 2, minus x is 0 is 0. So if we could simplify it further, 4 over k e to the power 2k. That is the area A. But area A, if you look at it, B part, using the results from part A, which we have the A area, or otherwise, but of course we have to use part A, find the value of k such that A equals 16 over k. So that area is given 16 over k for part, this is B, D. Is it D? It is, okay, so D. So right, area 16 over k. Area we found here is 4 over k e to the power 2k. So if you could equate both of them, k in the denominator cancel out, and common for the 4 common, and 4 and 16, and left with 4. So 4 equal e to the power 2k, and if you could log both sides, ln both sides, it gives you the left hand, right hand side is 2k, and left hand side ln 4. So k equal half ln 4. Half, when you do these, that's logarithmic. So ln n time ln m equal ln m to the power of n. So here, half time ln 4, that is equal ln 4 to the power of half, that is ln 2. That's what we have here. Thank you. Please subscribe the channel and share these contents to other students. This is a past VCE question. Thank you.